All right, so we're on to 6.2, which is factoring with trinomials. So taking things that have three terms, so trinomial, and breaking them into their product of factors. So basically doing the exact opposite of FOIL. So if you remember when you think about doing FOIL, we have something like, oh, I don't know, x plus 2, x plus 3, and we do FOIL, it's first, right? So x to the second, outsides plus 3x, insides plus 2x, and then last plus 6. And then we can combine like terms if we have them. So x squared plus 5x plus 6. We know how to do that, that distributive property or double distribute. What we do when we factor trinomials is we are starting with the answer. It's kind of like Jeopardy, I guess, right? And we're kind of trying to go work our way back to what was the question. So where does that come from? So this x squared coming from the product of the first, this 6 coming from the product of the last, and this 5x coming from the insides and the outside. So being able to take a look at those two terms and put them together. So we're working backwards. We're using FOIL, and we're going to work back to try to figure out where that came from. So that's kind of our process for today. So we're going to work through all sorts of different ways that we can do that factoring. So let's take a look at one so we can dig into this. So think of this as your answer. This is something that's already been multiplied out, a squared plus 9a plus 20. What you're shooting for is what two binomials can I multiply together to get that for an answer? So you're going backwards from FOIL. So we're trying to figure out what that distributive was. So remember, this a squared is coming from the product of the first. The 20 comes from the product of the last. And this 9a comes from what I call the OI, the outsides and the insides added together. So what we need to figure out is where those things are coming from. So let's start with what we know. How do you multiply two things together to get an a squared in those first positions? Well, that has to be an a times an a to the first times a to the first. So if your leading coefficient is a 1, life is good because there's really only one way to do that. A times a is the only way to get a squared. Now we can direct our attention to the last. It's a 20. So whatever in this last position of each of those binomials has to multiply to 20. So our first step is to figure out numbers whose product is 20. So can you think of the list of everything that multiplies to give you 20? We'll make our whole list. So we can do 1 times 20. 2 divides into 20 10 times. We could do 4 times 5, and I believe that's it. Try to be organized. Make sure you have your whole list. The only thing that this can be then is from this list. So either it's 1 times 20, 2 times 10, or 5 times 4. Well, how do we know which one it is? Well, the insides plus the outsides, right, our OI, has to add to that 9a. So we want to find the pair whose sum to 9. So we have to take a look and see what their sums would be. So that would be, the first one would be 1 plus 20, that'd be 21. 2 plus 10 would be 12. And then the last one would be, oh, there's our 9. So this is the pair that we're looking for. So we want the 4 and the 5. Let's talk about signs for a second, because that's another really good thing to look at. If you're multiplying to a positive 20, how do you do that? How do you multiply to get a positive answer? Well, the signs have to be the same, right? So they have to have the same sign. So it's either a plus times a plus, or it's going to be a minus times a minus. So how do you think we're going to tell if it's a plus times a plus or a minus times a minus? Look at your OI. What's the sign? I want a positive 9a. The only way to get that is by doing positive 4 plus positive 5. So they're both going to be positive. So that means in my binomials, I need a plus 4 and a plus 5. Now you could write it in the other order, so you could say a plus 5 first and then a plus 4. Those two binomials can shift. It doesn't matter because ultimately when you multiply them together, we have a 5a for the outsides and a 4a for the insides, and when I add those two terms together, I get my magic 9a that I'm looking for. So when I think about factoring trinomials, it really comes down to what multiplies to that last term and adds to the middle when that leading coefficient is a 1. Other great things to look at is the sign of that last term. It will tell you what the signs have to be in the binomials. All right, so let's try another one and see if we can kind of conquer this reverse FOIL idea. So we want to try to factor into two binomials. So we're looking for that product of two binomials. So we have, again, the leading coefficient is a 1. Notice, see that? Out front, the b squared is just a 1. That makes this easier. All right, so the first term comes from the product of the first. try to color code a little bit on this one. The last term here comes from the product of the last. So when we think about where these things are coming from, that's what we're looking for. All right, so how do we get a b squared? Well, that has to be b times b. I have no other option. B times b is b squared. When I do FOIL, when I do my first, I'm going to get a b squared. All right, now the next part is looking at this last term. How do I multiply to get a 10? So things whose product is 10. All right, so let's think of everything that multiplies to 10. Well, 1 times 10 is always 1 times the number, and then 2 times 5. Those are your only options. So if this is going to work, that's what we have to have. Notice it's a plus again. So that means the signs have to be the same. So the signs on my number have to be the same on each of those numbers. That's the only way you can get a positive 10 by multiplying. So either plus times plus or minus times minus. Okay, how are we going to tell which one it is? Look at your middle. It's a negative 7. The only way to add to get negative is if they're both negative. So I know immediately that if this is going to work, they both have to be minus because they will multiply to a positive 10, but they're going to add to a negative in the middle. All right, so our last quest, how do we know which pair to pick of these two? Let's calculate their sum. So we have a 1 plus 10, that would have given me an 11, and we have a 2 plus 5, which gives me a 7. So which pair do I want? Well, for sure, I want the 2 and the 5. So it's going to be b minus 2 and b minus 7. Their signs are the same. That's how you multiply to get a positive 10. So remember, on our outsides here, then, that would be a negative 7b. Insides, we get a negative 2b, which adds to that. Oh, I'm sorry, not a 7. I wrote the wrong thing. Sorry. That's a 5. Goodness gracious. So we get outsides a negative 5b. 7 is my answer when I put them together. And a negative 2b. So b minus 2 and then b minus 5. And again, we could go in the other order if we wanted to. And that would be just fine because it's just switching the order of the binomial. So we're looking for things that multiply to the last and add to the middle. If that last term is a positive, it's really nice because we know the signs are the same. All right, let's take a look when the last term isn't here. Let's see if we can figure out what's happening. So let's take a look and see if we can break this down into a product of two binomials. And again, this leading coefficient is a 1 again. So we know that that's going to make this a little bit easier process. So t squared, that comes from the first. So that would be in what goes in the first position, which would be t times t again. No other way to do that. The last is what I want to talk about. Let's take a look at that. So it has to multiply to a negative 5. So it's ever in the last position. Now, what numbers have a product of negative 5? Well, the only way to multiply to get a negative is if you have one positive and one negative. So the signs have to be different. And there's only one set of numbers that multiplies to 5, 1 times 5. So either this has to be negative 1 times positive 5 or positive 1 times negative 5. There are no other options. Those are literally the only things that multiply to negative 5. Okay, well, here's the issue then. Do either of those possibilities add to that number in the middle that it's supposed to? I know one has to be a plus and one has to be a minus. Do either of these pairs add to 3? Well, negative 1 plus 5 is 4. 1 plus negative 5 is negative 4. We don't get the right number either way. In other words, there's no numbers we can fill into those slots that will generate this polynomial. No whole numbers anyway, no integers. They call this prime. In other words, it is not factorable. There is nothing that we can do to break that down. There are no numbers that multiply to a 5 that add to a 3. It physically can't be done. These are not real solutions. So if we think about this parabola and we graphed it, what it means is this parabola, that t squared shape, this u shape, is not crossing the x-axis at integer values. Either they're imaginary, where it's not crossing at all, or they're crossing at places that aren't whole numbers. So we can't do any factoring there that's going to give us integer value answers. So it's good to be able to recognize when we can't do something as well. All right, so now we're going to bring in what if there's more than one variable. This really stresses people out, but the process is exactly the same. We're going to try to figure out if we can break it down into two binomials. If there's two variables, it just means you have variables in each position. So let's see if we can sort out what that means. So let's talk about this p squared again. Comes from the product of the first, and it's a 1. Once again, makes life easier. So that means I'm going to have a p times p in the first position. So I have that variable. Now let's take a look at the last. So the last position here. So this is the last. We want things that have a product of 6. So we want a product of 6, but it also has to be a 6q squared. So let's talk about the q squared part. If you're going to get a q squared, where would that come from? Well, Q times Q. So it just means in the last position, whatever the number part is, awesome, but you're going to have a Q with it, because when you do your last, we need to multiply to get a Q squared. So just like you could have a variable in the first position, you can have a variable in the last position as well. Okay, so let's talk about the 6 part. What multiplies to 6? List your factors. So 1 times 6, and then what's your other choice? 2 times 3. All right, now let's take a look at the signs. It's a positive again. So what do you know if you're multiplying and you get a positive? The signs have to be the same. So that means, once again, it's either plus times plus or a minus times a minus. There's no other option. How do we tell? Look at that middle term. Only way to add to a negative is if they're both negative. So that means it's going to be -1 times -6, and it's going to be a -2 times a -3. Both of those will give you that +6 result. Okay, now which pair do I pick? I want the pair that sums to -5. Okay, well, let's see which one adds to -5. -1 plus -6, that puts me at -7. That's too big. -2 plus -3, bingo, that's the one we want. So we want the pair -2, -3. All right, so what does that mean? We need to fill that in to our binomials. So that means it's going to be a -2q and a -3q. So I'm filling it into both. So when I think about doing FOIL, let's check our outsides. That would be -3pq. Inside's -2pq, which adds up to our -5pq. So with the extra letter, it kind of stresses people out, but really it's exactly the same process. You just have a variable in the first positions and in the last positions. What you do with the numbers is exactly the same. All right, let's take a look at number 4. This is going to pull together what we did in section 1 and 2. Before we start trying to see if we can factor into these trinomials into 2 binomials, we want to take a look and see if there's anything we can pull out first, any common factors. So I want you to look at those 3 terms. Look at the numerical values, a 3, a 12, and a 15. What divides into a 3, a 12, and a 15? In other words, we're looking for a GCF here. For sure, 3, right? I can take a 3 out of everything. How about variables? I have an a cubed, an a squared, and an a. Don't all of them have at least an a in there? So I can pull out that GCF of 3a. Now, remember when we did GCFs, if you start with a trinomial, 1, 2, 3, I'm going to have 3 terms on the inside. Remember, if I multiply this back through, it has to give me the same original trinomial. All right, so 3a times what would give us 3a to the third? Well, I need 2 more a's, so a squared. And then 3a times what would give us 12a squared? Well, 3 times 4, so plus 4. And then a squared, I only have an a. I need 1 more a to the first. And then 3a times what is going to give me a -15a. So 3 times 5, but I want to make negatives. That means it has to be -5. And I already have the a, so a times that 5 will give me that 15a. So we pull out that GCF first. Now what that allows me to do is I can take now this trinomial, a squared plus 4a minus 5, and I can see if I can break that down further into those 2 binomials. So can I take this trinomial and write it as 2 binomials? And then the 3a is just still part of the product. Because again, remember, when I multiply everything back together, I have to be able to get back to that original trinomial. All right, so let's see if we can do that. We're going to do our reverse FOIL here. So remember, this comes from the first, so in the first position. So how do we make an a squared? Well, the only way to do that is a times a. Now we'll go to our last. So a -5. So that's from the last. So what goes in the last position has to multiply. So it has to be a product of -5. So how do you multiply to get a -5? Well, you either do 1 times -5 or -1 times +5. We have no other options. What do we want them to add to? Well, look at your middle term. You want a 4a. So which of those pairs add to 4? Well, let's add them up. How about 1 plus -5? Well, no, that's -4. -1 plus +5, there we go. That's the one we want. So that's how I know which pair I'm going to pick. Because it's a negative, I know my signs have to be opposite, right? That's the only way to multiply to a negative number. And I want my 5 to be the larger absolute value because I want to make a 4a, a +4. So let's double check and make sure that that makes sense. outsides, I would get a positive 5a, insides a negative 1a, which adds to that 4a in the middle. So it's usually a pretty quick check to make sure that you are correct with your multiplication. So if I look at these three factors then, so there's three factors, if I multiply them all back together, so did FOIL and then multiplied everything by 3a, I would get right back to that original. So the whole idea is pull out that GCF first so you can see that you can factor further with that trinomial. All right, so we're going to finish up today with one of these, and then we're going to practice a bunch more tomorrow. We're going to deal with the fact, what do you do if the leading coefficient is something other than 1? Life gets a little bit more complicated because there's more possibilities to try. It is a guess and check. It's kind of a glorified guess and check here, but we still want to do our best to see if we can figure these out. So first thing to check for is GCF again. Problem is 6, 19, and 10 have nothing in common. So I can't really pull anything out, because if you could, that always makes life easier. All right, so let's do our color coding here. We'll put in everything we can. So that comes from the first terms, right? So the product of the first. Notice there's a k squared. So for sure there's going to be a k times k. Now the problem is there's also a 6. So I need to think about things that multiply to 6. So things that multiply to 6 would be 2 times 3 and 1 times 6. Those are my possibilities. All right, now we're going to go to the last. So here's my last term. So this is the product of the last, and notice it's positive. We need things that multiply to 10 for that last position. So 1 times 10 and 2 times 5. And remember, the signs have to be the same because it's a positive, right? So the signs have to be the same. So it's either plus times plus or minus times minus. Let's see if we can figure out which it is. Look at your middle term. The only way to add to a negative is if it's minus times minus. So a few more things I can fill in. I know they're both going to be minus. Other than that, I can't really fill anything else in yet because I have to figure out when I do my outsides plus my insides that I get a total of that negative 19k. That's what I'm going to be looking for. So I want to find something that adds to negative 19. So that's what I'm shooting for. Now I'm going to have to do a little bit of guessing and checking then with these different pairs. Maybe it's the 2 and the 3 with the 1 and the 10. Maybe it's the 2 and the 3 with the 2 and the 5. Or it's the 1 and the 6 with the 1 and the 10. Or the 1 and the 6 and the 2 and the 5. There's really 4 different possibilities to try out. And we're going to do some guessing and checking to see what makes that happen. So we're trying to make a 19. So we have to think about what pairs of numbers will do that. So I'm just going to take the first one I listed here. I'm going to guess that maybe it's the 2 and the 3. This is, again, a kind of a guess and check. I know those numbers work because I picked them because they have a product of 6. Now to pair with that, I need to do some guessing and checking. 1 times 10, if I multiply those numbers by 10, that's going to get big really quick. Think about that. If you put 10 in either of these positions, that's going to be a pretty big number already, and we only need to make 19. So I don't think it's probably the 1 and the 10. I'm going to try the 2 and the 5. So let's try putting them in either direction. So we're going to see what happens when we do that. So let's put together some options. So I can put the 2 in the first position and the 5 in the second position. So that could be a potential. Or we'll just try it the other way here. I could put the 5 here and the 2 there with my 2k and my 3k. Now, I want you to see how we can try both of these possibilities. Maybe neither of them work, and then I have to go back to the drawing board and maybe try the 2 and the 3 with the 1 and the 10. Or maybe it's the 1 and the 6 and the 2 and the 5. But before I can go on to anything else, I have to check and see if these work. How do you check? None of these just automatically added to 19, right? None of this does. It's the OI, the outsides plus the insides in FOIL that have to add to the 19. So let's see if we can get either pair to do that. So let's try it here. So 2k times a negative 5 would be negative 10k. And then negative 2 times positive 3 would be negative 6k. Add those together, what do you get? That looks like negative 16k. So that means this doesn't work. That's a no. But before I eliminate those possibilities, I have to try them the other way around. The 5 with the 2 and the 2 with the 3. So let's try over here. So outsides, 2 times negative 2 would be negative 4k. And then negative 5 times 3 would be negative 15k. Oh, look at that. So negative 15, negative 4, there's my negative 19k. So the outsides plus the insides have to give me that negative 19. So that's the pair that I wanted. So it wasn't my first attempt, but at least I picked the right pair. Sometimes you have to go through a bunch of possibilities to see what works, because it's not just, oh, I can look at the last and figure it out. because that first term's a 6, those are factors that have to be considered as well. But it literally is a very short list of guess and check. There just aren't any other possibilities. And if something's going to work, it has to come from that list. So we'll do a lot more with that in part 2. So this is just to kind of get us started with making sure we know how to multiply or factor with 2 binomials and being able to pull out a GCF first as well. When the leading coefficient is 1, fantastic. If it's not, we're going to have a little more work to do. Look at your signs. Look at that last term and see if it's positive or negative. That will help you determine the signs in your factors.